In question number 20, a tank is full of water. We want to find the work required to pump the water out of the spout. So we have a circular tank here with a radius of 3 meters, and the length of the spigot is 1 meter. So now we're going to use the equation of a circle, and we know that x squared plus y squared is equal to 3 squared since the radius is 3, and then we're going to solve for x. X equals the square root of 9 minus y squared. Now in step 1, we're going to let y measure the depth meters below the center of the tank, so that y equals negative 3 at the top of the tank, and y would equal negative 4 at the spigot. It must be lifted y plus 4 meters by the pump. In step 2, we have a horizontal slice of water delta y meters thick, and lying at coordinate y has the radius of the square root of 9 minus y squared and a volume of pi times the radius squared delta y. We're going to substitute r to be the radius that we found to be the square root of 9 minus y squared times pi times delta y cubic meters. Now we need to figure out the weight. So the weight is going to be about 9.8 times 1,000 times pi times 9 minus y squared delta y joules. And now we're going to apply this function to the integral designed for work. So in step 4, w is going to equal a lower limit of negative 3, an upper limit of positive 3, times 9.8 times 10 to the third power, times y plus 4, times pi times 9 minus y squared dy, where y plus 4, again, is the amount that must be lifted by the pump. So we're going to factor out the constants, and now we're going to integrate from negative 3 to 3 of this function, 9y minus y cubed plus 36 minus 4y squared dy. Okay, now, since we're going from negative 3 to positive 3, okay, we can look at the theorem of 5.5.6. So before we proceed, I'm going to scroll down here so you can see this theorem. Now recall that suppose f is continuous on this interval. If it's an even function, then we can apply this rule where it's going to go from 0 to 8 and multiply this by 2. Now if it's an odd function, then we know that this is going to give you 0. So when we come back up to this function here, currently when you look at this entire function, it's odd. So we cannot apply that rule because that means that this entire thing would be 0 times all of this. But we can separate this integral in two parts. So we can separate the first part going from negative 3 to 3, 9y minus y cubed dy, plus negative 3 to 3, the second part, 36 minus 4y squared dy. And what happens here is that this becomes an odd function, and this becomes an even function according to that theorem. So since this is an odd function, going from negative 3 to 3, it automatically becomes 0, again because of that theorem. And since this is an even function, then we can factor out a 2 and now go from 0 to positive 3 of 36 minus 4y squared dy. And so now what we can do is we can factor out the 2, and now we're going to integrate this even function that goes from 0 to 3. So we're going to get 9.8 times 10 to the third power times pi times 2. The antiderivative, 36y minus 4/3 y cubed. And then we're going to evaluate according to the upper and lower limit. So we'd have to evaluate it according to the value of 3. And so if we multiply all this out, we end up getting 1,411,200 pi, which is approximately 4.43 times 10 to the 6 joules.